Hello, I'm Minchu Cha.
Hello, I'm Dongwon Chen.
In computer programming, it is necessary to create a variable that is a memory location to store a value or data. In this lecture, we're going to explore and learn what the arrays and array lists are. Basically, those two data structures are the structures that store variables, which usually are related to each other.
The reason why those concepts are important is those structures allows us to expand the diversity of programming. More detailed information will be explained throughout the lecture. So let's have a look.
First, we will explore arrays, then array lists. And to understand 2D arrays, it will be very useful to have a look at one-dimensional arrays. In this lecture, focus will be mainly on one-dimensional arrays because it is a basic of the rest of the arrays. As it is mentioned, an array is an object and at the same time is a data structure used to implement a list object. Since it's a data structure, you can store multiple data unless your computer memory gets full. So you could use an array if you want to create a collection of variables. Admittedly, for some programs, it is possible to achieve the same goal without using arrays, but the algorithm will be much more complicated and it will be less efficient in utilizing memory, because you might have to use more loops or conditional statements.
The basic format will be like this. You first have to declare its type and specify it is an array then the name equals, which is an assign operator, and keyword new and type of array and its size. The reason why you're using the keyword new is because array is an object. Let's look at the code. Same with storing variables, you have to first declare the array and initialize it. These are the examples of initialization of array. Int, double, boolean, string, class. These are the 5 most frequently used declaration in AP Computer Science. Since the array is declared, the elements are automatically initialized for each data type's default value. The array can also store a fixed size of collection. Therefore, you have to be careful with its size when you're creating them, because the size can be changed once it is created. The array index position starts from 0, so the end index position is always length minus 1. You could see the start position of the array is 0, but ends up at the index position 5, although the length of the array was 6. Therefore, if you're traversing the array, you have to be careful on setting a condition for each loop, either for a loop, for while loop. Just like strings, we use .length after the array variable to get the length of the array. Array.length. But there are no parentheses after the .length in order to directly access a field member of an array. Now, you'll be curious how those values were initialized to each index position. When you're using an array, you always do not want to put the default value. The basic way to initialize each index positions are like this. It could be easily interpreted as value is actually being stored in the area, but surprisingly, for each index position, the array is referencing the element. But these initializations are quite a bit inefficient in both time and memory perspective, so we often traverse arrays by for loop, in for loop, and while loop, and overwrites the values.
Basically, for for loop and while loop, every loop we are overriding a value by accessing the position I. As the for loop executes, it allows us to access to each successive position of array as the I increments, until the array position length minus 1. Therefore, we are setting a for loop condition as I is less than the array's length. This logic also applies to while loop, but you must create an instance variable which stores 0 and increments its value by 1 every time it accesses the array's value. However, for enhanced for loop, it is impossible to directly change the value inside of the array because the enhanced for loop variable, which is A here, is only referencing the value of the array, therefore it does not have an access to modify the value inside of it. But still, if you really want to use the enhanced for loop due to a safety on index out of bound exception, you can create an instance variable just like a while loop and access the array then override its value. This is memory inefficient compared to for loop and while loop. Therefore, we do not recommend you to use enhanced for loop, although it has more safety on preventing out-of-bound exception error. It is memory inefficient because you have to create more instance variable, which takes more memory in computer.
Since you initialize or overwrote the values in the array, you must check the output. And this is how you print all the values in the array. You couldn't just simply print the array but system.out_print because it's an array. So it will print out the location where the array is stored in the computer. So you don't have to traverse through the array or use arrays.string method to print the array.
Printing an array works as very similar as how to modify the value inside of the array. We're accessing and traversing the array by using loops, then just use system.out_println or print to print out the value. However, you can also use a method that already exists in Java, which is arrays.toString_parameter. Inside of the bracket, you will put the name of the array to directly print out the value.
Advantages of using these loop traversing methods are: first, you can print out the entire array. Second, you can modify the loops and applicate them to achieve a goal such as printing odd or even. We'll further look for some famous algorithms that are actively being used in arrays. This algorithm can be applied to other concepts such as 2D arrays or Arraylists.
The algorithm basically operates like this. While traversing and accessing the array, the if statement will be determined if the number is odd by using modulus. And if the number modulus by 2 is not equal to odd, it will mean that it's an odd number. And for the even numbers, we will use the same logic but simply change the if statement condition to the value modulus by 2 is equal to 0, which means the value is even.
The range of application is very large, so you can actively utilize your creativity by using arrays. Utilizing the loops is very convenient to selectively print out the values in the array. However, although you're not traversing the array, you can still print out the values by directly accessing the index position. But it is so inconvenient to print out the array, so we strongly recommend you to use traverse to print out the array. Please apply the knowledge that we just gave you to solve the question.
So now we're going to have a look at some questions that me and Dong made. The question says, we have to create a method that finds and prints out the maximum value inside of the array. So we have to create an instance variable called max and initialize it with the value that is stored at the very first index position of the array, which is test score 0. This is because we have to fully traverse the array from the beginning to the end index position of the array. Then use the if statement to find out the maximum value of the array, which is when test score I is bigger than test score 0. Maximum value will be overridden by test score, and this process will be repeated until the loop is ended. This logic will be very similarly applied to finding minimum. You just need to modify the if statement condition to when test score I is less than the previous value. Lastly, we'll have a look at finding the average. We have to create 3 instance variables called sum, count, and average. We have to traverse the array to get a sum value of the array, and for each traversal count, will be incremented to know how many times that the for loop was executed. And when the loop ends, we can divide sum by count to have an average value and print them out.
Array is a useful tool that is actively being used to search for the certain value. We are assigning a value to an integer value called maximum, and we are assigning a value by selecting the element in the index position of the array by referencing the variable followed by index, so it becomes max equal array bracket I bracket. Therefore, the for loop will keep traversing through the array until length -1, and it keeps updating the maximum value if it satisfies the condition. The reason why these concepts are being specifically applied is because those algorithms can be applied to both to the array and array list, although some of minor differences can be made. To the array is basically an array that stores an array inside of it, just like a matrix, which is a collection of rows and columns. In AP course, you can use boolean, int, double, string as the type of your array. This is basic format of declaration and initialization. First, you have to declare the type of the array, then indicate it is the 2D array and name equals the new keyword array type. So far, there's no big difference between one-dimensional arrays, and here's the difference. When you're initializing the 2D array, you must set the numbers of arrays, which is the number of rows, and for the next square bracket. We initialize the number of columns, which is the length of the row. The basic format of initialization will look like this. Just like one-dimensional array, since the arrays are created, the default values are initialized. And very similar to one-dimensional arrays, you can also directly initialize or override the value like this. C. Putting an array inside of an array. If we visualize those values in matrix form, it will look like this. Since the size of the matrix will be 3 times 3, which is row x column equals 9. Following the transition value 3 is located at the position 0, 0, so 4 is located at the position 0, 1. However, this process is too manual and inefficient, so you can also traverse the array to initialize, override, print out, or to put other actions. Let's have a deeper understanding of traversing the 2D arrays. In Java, 2D arrays are stored in row major order, which is sorting data in a direction of row, like row by row, storing all data in the first row and second row and goes on. First, we're going to look at the row major and then column major.
First, let's have a look on raw major. We're using nested for loop because we have to have two instance variables to access the 2D array since it stores a value by row and columns index position. When the outer for loop executed, inner for loop must be fully completed. Therefore, we're setting ARRIJ so that if the traversing row is 0, they will fully traverse the row, since it's an inner for loop instance variable and it means the length of the row. And reversely, column major works just right oppositely as row major traversal. I will be incremented onto the length of the row -1 and j will be incremented onto the numbers of row -1. And the array will be accessed by ARRJI because in this time, columns must be fixed and the row must be incremented to access the array by column form. Now, we will look at how the 2D array can receive the value from the user. This algorithm is very similar to the algorithm that is shown previously. You just need to use nested for loop to access the 2D array and receive the input from the user by using scanner class. It can be printed on your own favor, but I want to introduce one convenient way to print out the values in 2D arrays, which is enhanced for loop. You also have to use two for loops. Basically, in the first for loop, you're receiving the whole row of the 2D array and store the value of the array into the second for loop's instance variable.
Lastly, let's have a look at an array list. Arraylist is a class that provides an alternate way to sort a list of objects. You can simply think of it as a mutable list of object references. It's a part of the Java util package, so if you like to use Arraylist, you have to put a statement such as import java.util arraylist, import java util at the top of the coding. The big difference between Arraylist and 1D and 2D arrays are the size of the array list is resizable and easier to modify after it is created, so you can use Arraylist when the value and size needs to frequently be changed. It's just like a rubber band. However, the basic structure of Arraylist is like an array. And the basic format of initializing Arraylist will look like this. And for data type, to store an int, double string, or boolean values, we must use each wrapper class because it only stores the object references. Unlike one-dimensional and two-dimensional arrays, you must use the following method to modify the array list after it is created. Methods are array.size. It gives you a size of the array. Array.add. .add method as an object at the end of the array list. You can also write the .add method by selecting the index where the element will be placed. Since the element is placed in the certain position, the rest of the element that follows will shift each index to the right size. Array.get. It returns the element at the specified index in the list. Array.set. It replaces an item at the specified index in the list with a specified element. And if the specified element does not match with the type of the array that is declared, it throws on a runtime exception error. Array.remove. You're removing the element in the certain index. Therefore, the following elements in the array list will automatically shift to the left index position corresponding to the numbers that the elements are removed. The size of the array list will shrink as well.
This is a demonstration of using methods. One thing you have to be careful about .remove method is if you're using a method like this, it doesn't remove all the indicated values but the value that is placed first in the array list. And we can directly print out the array list since Java automatically uses the toString method in the array list class. Therefore, the values are being printed out but not its addresses. We have invited Mr. Song to sum up the ideas.
Likewise, Arraylists could execute the program that has the same algorithm that was created by Array, but keep in mind that the methods just explained must be utilized. Now, I believe we do know about those concepts. To sum up the ideas, advantage of using 2D array. It is used to represent multiple data items of the same type by using only a single name. It can be used to implement other data structures like linked lists, stacks, queues, trees, graphs, and etc. 2D arrays are used to represent matrices. Disadvantage of using 2D array. Array is static structure. It means that array is of fixed size. Since array is of fixed size, if we allocate more memory than requirement, then the memory space will be wasted. And if we allocate less memory than requirement, then it will create problem. The elements of array are stored in consecutive memory locations, so insertions and deletions are very difficult and time-consuming. Advantage of using array list. You can define array list as resizable array. Size of the array list is not fixed. Array lists can grow and shrink dynamically. Elements can be inserted at or deleted from a particular position. Arraylist class has many methods to manipulate the stored objects. Disadvantage of using arraylist. Data entry. If new data is added or removed from arraylist, then its data needs to be shifted to update the list. If arraylist has n numbers of data, then an add or removes will take O of n times. Capacity. Arraylist also has performance limitation. If you don't specify initial capacity, then by default, it allocates its initial capacity, which is 10. Every time when Arraylist hits its own capacity, data will be copied from old to new space with 50% more capacity.